generic.
Okay, so we have different accessible.
Like your sound is not coming clearly.
Come again.
It's now better.
Come again.
It's fine. It's fine. Initially, it wasn't quite clear.
Oh, okay. They said it wasn't quite clear.
Have they connected?
Yes, they have. Okay, so it is time, so we will start. I know the license is an issue, availability of license is an issue, but the one license is not for only one person. As and when you want to do something, you just have to install the company leapfrog on your working machine, and then you just have to ask for the license and then do whatever you want to do. Maybe practice, you want to practice. So the license is not for only one person until we get another license and then add. Okay, so we know that leapfrog has taken over the explicit way of modeling. Leapfrog is actually an implicit way of modeling, whereby you select your drill holes to snap to, the samples, rather than using segments or strings, digitizing strings around your whole body. So, and a lot of companies have moved to leapfrog. I hardly see companies using Datama wireframes or SEPAC solids to run estimation. And so they need to just have a refresher. I know a lot of you already know how to construct a mesh in leapfrog. This is just for us to remind ourselves the process, how to go about it. So if you can see my screen, there are procedures or methods when you are going to construct a wireframe in leapfrog. First of all, you have to develop a sulfide boundary. I know over here we say the parite is our interest, our mirror of interest. So you have to develop a sulfide boundary, and that will envelop all your data. It means that outside you wouldn't find any mirrorization. And the reason why we are developing that one is not actually going to be used for the major estimation, but it's just to be used for our domain zero. You know, when you are able to select all samples inside the loss, or you call it meshes. In leapfrog we say meshes. In Datama we say wireframes. In SEPAC we say solids. They are the same. It's just terminology differences. So when you select all your data inside your loss, definitely there will be scanty or spotty samples that will not be included in the loss. And in the estimation, that is what we call the domain zero. They are far away, they are discontinuous. So you can't put everything inside your wireframe or your mesh. So some will be left out. So the reason why we are constructing this sulfide boundary is to envelop all the samples that we have, so that at the end of the day, we will have to we'll have to do trifill and then get a model outside our loss, and that will be our domain zero. We will use that to estimate our domain zero. So we just need a broader wireframe or a mesh to be able to run that estimate. That is our domain zero. So in leapfrog, that is the first thing, the first wireframe, your your sulfide boundary or your sulfide envelope. And then afterwards, you develop your shears. It's not the shear zone that we know. That shear in leaf rock is actually an area where your mineralization is concentrated. You have an intense mineralization at a certain point. If you look at the sample, you have a trend. There's a trend. Okay, so you have an intense mineralization at a certain point, and that is what you are constructing a shear. And in other words, the hanging wall footwall. It's not the footwall that we know in geology that when there's a fault, the plane of the fault, the block that is at the upper part of the fault is the hanging wall, and that the one that is lower is the footwall. Or the old definition that the place that the miner hangs the lamp is called the hanging wall. The place that the miner hangs his foot, steps his foot, is called the footwall. It's not that one. It's just two surfaces. That is actually a wireframe that is enveloping your mineralization, the intense aspect of your mineralization. So when we begin, you will understand that. And then afterward, after the shears, they will now go to the mineralized loop or the wireframe.
Eric should switch off his video.
Okay, so yeah, so after you construct the shear, then you come to the nose, and that is where you have series of load. Isasi ore body, we don't use the vein system for the modeling. We use what we call the indicator, where you have you say, okay, samples that are greater than a certain threshold, for example 0.3, should go inside the shell, and samples that are below 0.3 threshold should go outside the shell. And you will have a very big wireframe, and after that you use your 4 zones to demarcate each of them. Over here, this place, what do you call it, Akwesisu Incline, and the other piece, I think some of them, most of them use the vein system, which we are going to tackle, and after that we'll go to the indicator system.
Yeah, Clint.
Yes, sir.
The terminologies are a bit different and confusing.
Okay.
You see, when we're talking about underground, we're talking about the loads. But when we come to the surface, we're dealing more with domains. So they are the same thing.
Yes. So they are the same thing. We call them loads, and we domain them, and we call them domains, domain 1, 2, 3, whichever you want to call them. So domains and loads are the same. Domains and loads are the same. Actually, the sulfide boundary I've already explained. That's where your domain 0 is. Hello? Yes. Are you using your phone, or you are using a PC? Increase your volume and let's see. Wow. Yes, I'm active. Wow. Okay, you go out and rejoin. Go out and rejoin, and let's see. So sorry, somebody is not hearing me. So yeah, so what the senior citizen is saying, domains are the same as the loads, they are the same as the wireframes. So just like I said, wireframes are the same as the meshes, they are the same as the solids, but just that different softwares and then the terms they use. But when we talk of domaining, we are just trying to say a group of things with similar features or characteristics. So you group them. So this is a domain 1, domain 2, domain 3. For example, in the chord veins, where for instance, where you have a lot of chord veins, you can get a grade of 50 grams and above. So automatically, usually because the chord has higher grades, we assign them as the chord domain. So we are just grouping similar things. That is the domaining. So when you come to the domain 0, the ASP boundary, I said that you used to estimate the domain 0, is actually mostly weights. So they are, that's a group of assays that do not have good grades mostly, but sometimes, like I said, you have patchy high grades within them. But if you cap them, yes.
Yeah, ladies and gentlemen, well, you got to lift up your hand and ask question if something is not going very clear to you. We know that the introduction, we've been introduced to the sulfide envelopes. But if you come to our setup at Sanko, we don't have the sulfide envelopes because our style of mineralization is a little different from Obuasi underground. If you go to Obuasi, the mineralization is more associated with the sulfides, which is predominant more of the arsenopyrite, as well as the veins and the shears. So if you don't understand anything, just ask a question that where is the sulfide envelope? Okay.
Okay, so I think I hear that you people, arsenopyrite is associated with your gold. Pyrite, right?
Yeah. They call
Am I correct? Hello, I can't hear you. I understand you said the pyrite is associated with your gold. Is that right?
Yes, good.
Yes.
In encrine, there's a strong association with the gold as far as
Okay.
encrine is concerned. But like he said, the assay is quite different as far as the sulfide mineralization is concerned.
Okay, good. So let's take encrine for instance. If we are logging and we are getting pyrite. So at the end of the day, there should be an envelope. If for anything the pyrite wasn't recorded, that is why sometimes they do the domaining and then they use the pit solid or whatever to estimate the domain 0. That is the ideal thing. So if you don't have that envelope, you should have the pit that all the data sits inside, all your mineralization sits inside. Then you use that one to estimate your domain 0. However, these are theories. Let's go to the main thing so that we don't waste time. I'm launching leapfrog, so it takes a while. Okay, so if you launch leapfrog, this is what you will see you have your locals, you have your projects sitting on your locals, all projects you have worked with. So you go to new. If you go to new, you have to give the project a name. You have to give the project a name. So this is the name I've given it, Abori Project. So I want to, let me put my data in, I'm not sharing, or let me, can you see my screen? This, where is this? Where is this? Okay, can you see the Abori drill holes?
We can't talk, we can't hear their voices.
Can you see Abori drill holes?
Yes, we can.
Okay, so it's on my desktop, so I'm cutting it. I want to put it in my database. Okay, so if it is there, I want to browse for my project. I want it to be stored there. So that is where I want my project to be stored. So you okay it. So now let me go back to the project. Okay, so this thing we are not new. As is our measurement data. For leaf rock, whether it's in your form 2, whether your BHIDs are whole underscore ID or is BHID, leaf rock will accept. It's only determined when you don't have BHID. By default, you have the BHID form 2. Bearing represents azimuth that's determine will be looking for. And this is our spatial location. What will tell us our spatial location, which we're all familiar with. And we have our little, minerals, and then our surveys that gives us our directions. So that is what we are going to load. So you just go to drill hole data, then right click. So when you right click drill hole data, you have the first one, which is import drill holes. So these just they are CSVs located somewhere you want to import. That is the first one. The second one is the drill hole from via Central. It appears they were using Central, but they have, they have stopped. So you can import them via Central. You can also import the drill hole via, open database connectivity. It's just a database of, what the companies, if they are using ODBC, that's open database connectivity. You want to import from the database straight. That is where you go. And we have the last one is the Aqua. So ours is the CSV. So we just have to choose that first one. Then the order is the color first. So I'm going to my folder. So I select that. If you select the color, then automatically the interval tables comes in. There's one that is left. That is the mineralizations. So I just have to pick that one in addition. So these are what I'm importing. So
let's pause and ask our day. Okay.
are you? Is there anybody? Is there any question? Are you okay? Bishop, this one there is cool. From this type, this stage, yeah, okay. So, so now the first one is color. So you see that this is not imported. This is not imported. So you have to select those who are not important. If you want to import them, you select them. If you don't want to import them, you can leave. But we can decide not to import this data set or import them. It's not of any importance. So with this, they are category. You have letters. They are categories. If they are only numbers, they are numeric. So these are categories.
Hello, Chris.
So now BHID is already, the whole ID is already marked. So we don't have to do anything. So you come to the whole type. You can also take them as categories. The maximum depth has already been marked. The eastern, the northern, the elevations have been marked. This project, if you want, you can import. If you want, you can leave it. Actually, they don't have any importance in this our modeling. So, except that maybe with the project you want to filter. If you want to use to filter, if there are two different data sets, Abore and Nkra, and you want to filter, you can import it if you want. But everything is Abore, so we don't need it. So the second one is the survey. So take category. This has automatically mapped. If when you are importing, you need to take note of the dip. You see that over here the negative dip points down. It has been thick. If you don't check it, your drill holes will plot up. They will be plotting up. The collar will be down, and then the end of hole will be up, like you drill the hole from space. So it's good to check it. If you uncheck it, that is what will happen. But it's good to check it. I think this version of leapfrog automatically does that. So next, again, that is the axis. So category, this, that. So this one, sample type, if you want, you can import it. That is if you want to filter. If you want to filter, maybe you have RC and DD, and you want to filter RC alone, or you want to filter DD alone, you can bring it in. If you don't want to, so there's no need. AUPPM, everything is, they are numbers, decimals, so it's numeric.
So the negative values.
Yes, so the negative values, you can, if you want, the negative values, after that, we can omit them or replace them by 0.005, or we could have actually replaced them by 0.005 before importing, whichever we want it to be. There are some with no samples, there are some with negative values. So after that, you can decide. The lowest detection limit you can replace with 0.005. That's it.
And the blanks.
And the blanks, they are blanks.
Where we don't have any value.
Yes, where we don't have any value, if you want, you can omit them.
Yes, we should let them be aware of.
Okay, yeah, I just want to finish the import the error, then we'll see how the errors are being fixed. Okay, so next we have the little data sets category. We have this, that priority. I think everything here is zero, so we don't need it. Little has already been mapped, so I want to choose.
What's the meaning of the priority?
I don't know this data. That's about already data. I don't know the priority what it is. Maybe they prioritize them. I don't know. Everything here is actually 0, 0. It's 0, 0.
So we don't need that. So
You don't need it. You don't need it. So I want to give this. This is lithology. So that's lithology. So just choose lithology. Then oxidation has already been mapped. The regoliths and whatever. If you need them, we can import them later. So I think weekly oxidized. This is a weekly oxidized and fresh and whatever. So if you need them, we can import them later. If you want to import them to file, so that's it. So next. So the last one is the minerals. So I'm going to choose category, and that's I'm going to choose that's so you wait for it to import. Okay, so this is the data. You don't have errors in the color, you don't have errors in the service. You only have errors in the axis. So what you need to do is just right click and go to fix errors. So we have overlapping samples there. We have overlapping samples there. So these are overlapping samples. We have samples with no color. You have samples with no color, and we have no samples. We have no samples too. So we need to fix them before we continue. So the overlapping you can ignore. You can ignore the overlapping. Just select one and scroll down. Control. Shift rather. I've just highlighted one and press the shift key. So I'm ignoring that. So I'll just highlight one and scroll down with the shift key. So when you are done, you save. So these are samples with no color, so you can't go inside the hole and go and pick anything. Maybe if you have hard copies, whatever you want to investigate, you have the color you want to go back and refix. That is it. But if you don't have, you can do nothing. So that is it. So over here, these are the assays, no samples. There are no assays on them. It's just from 2, and some are negatives. So what you can do is, we have the missing value, so you can just replace them by 0.005.
Is it minus 0.01?
Come again. So we just the background value, I mean the lowest detection limit.
Ladies and gentlemen, this is training exercise. So please, if you want to ask question, just prompt and ask question. We want to replace all the absent records with 0.005, and no one is asking question. And we have minus 0.01. We want to replace it also with 0.005. No one is asking question. Do you understand why we are replacing absent record with 0.005? At the same time, we are replacing minus 0.01 with 0.005. And what is the meaning of minus 0.001 in our database? Please ask questions.
Okay. I think the labs differ. In Obuasi, the lowest detection limit is 0.005. The argument has always been that an assay cannot return, analysis cannot return 0, or it cannot return negative. So what they do is we replace our values with 0.005. And in fact, even in Asanko here, the script has been designed in such a way that any value that is less than 0 or 0, it is being replaced with 0.005. But the samples that come, what I see, the lowest detection limit is 0.01 or something. 0.01 here. So the reason why we are replacing it with 0.005, the 0.005 is the lowest detection limit. In fact, if you run an estimate, and then you get negatives in your, let's say, to bias your estimate. That is what I've understood. So we don't use negative to, run estimates. So that is why the script has been designed to remove zeros and negatives, and then replace by 0.005.
Can I see?
Yes.
Okay. Let me also chip in this one quickly. Maybe someone might ask, why are we not using, instead of 0.005, why are we not using 0.001, but rather 0.005? Well, one school of thought in geochemistry, and it's an industry standard, that where the lab reports below detection for you. Take this: when the lab reports below detection, you want to convert that into numeral, that is number. You take the lab detection limit and you divide it by 2. So at Sanko, our lab detection limit is 0.01. And 0.01, if we divide by 2, you get 0.005. That is why we replace all our detection limit values to 0.005.
Senior fellow is talking.
Okay? Do you understand?
Yes, sir. Yes, sir.
Okay.
Thank you.
Like,
Yeah.
Yes,
yeah,
sir.
I wanted
Yes,
to
sir.
ask a question.
Okay.
Yeah, in data mine, we try to incorporate the minerals in our lithology.
Mm.
But in this very case, I've seen that you are separating these two data, the lithology and then the mineralogy. Is it because of the envelope that we may want to buy the sulfide envelope that we may have to develop? That's why we are doing that. Or is a requisite a requirement for you to get that mineralogy data?
I think the minerals they are also tapped on their own. If you are logging, you have from to maybe arsenopyrite. From this to this, we have arsenopyrite, that to that. So they have a tap on it. So in the database, when you are extracting, you have the minerals on their own coming out. Mineralization tab.
Okay, Eben, let me also add a little bit to what Cletton is saying. Well, we're separating the lithology from the mineralization field. That is your question. Why are we separating the lithology and the mineralization field, isn't it?
Yes, please.
Well, whenever you are dealing with geological data, you like to understand the data, the behavior of the data. And if you are taking lithology, for example, if you visit any of our pits, we have the major lithologies, the sandstone, the siltstone, the shales, and all those things. That's why you can log them. And when it comes to the mineralization, all that we can see from our drill chips are the sulfides, predominantly the pyrites and the arsenopyrites. And the sulfide could be found either in any, or it can be found in any of the lithologies. You can find it in the sandstone, the granite, the siltstone, the shale. You can find it in all these things. But the percentages will vary. You understand?
Yes,
The
sir.
percentages of this sulfide mineralization within the individual lithologies may vary. And you wouldn't know from scratch what controls your, we are interested in gold, what controls our gold. Is any of these sulfides having any relationship with our gold? So in this case, when you separate the lithologies from the mineralization, when it comes to the statistical analysis, or when it comes to the correlation analysis, when you are correlating things to see what to combine with what as a domain, okay, or as an envelope, or as a zone, then you have to relate one by one. Then the picture will come out so that you will say that, okay, now if I take the sandstone as a unit, we have sandstone units that are barren, no gold in it. And we have sandstone units with sulfides that may be mineralized. So if you do your analysis and you see that sandstone unit with sulfides has also gotten some gold, then in your envelope you can put them as one family. And the sandstone unit without the sulfides could also be in one family, though they all come under the clan of sandstone or come under the umbrella of sandstone, but they might be different people. Okay, yes, so that is the importance of picking all those details and bringing them as a different field, so that when it comes to the statistical analysis, trying to understand your data, you can use all these fields to relate to one another and come out with a story. Thank you.
You're welcome.
Okay. So and I guess in the tablet you have that field, mineralization.
Yeah,
That you record. Okay, so that is it about the import and then fixing of the errors. So I close it. So the next stage is called the grouping of lithologies. Grouping of lithologies. You have metasediments, you have metavolcanics. So you need to group them for the purpose of, for geotechnical purposes. If geotech people wants to know where is this place very hard rock? Is this place very soft? Is it deformed? Is this place graphite? For that purpose, and for the purpose of estimation, you know the rock strew, the density varies. That is also another thing. So we need to group the lithologies, and then if you want to model them, you model them differently. And then perhaps if there's graphite or chloritic schist that you want to also model them, then for geotechnical purposes. So that is also another. So we need to group the lithology. So to group the lithologies, you go to lithology. If you go to lithology, my cursor is on lithology, then you right click, then you go to where is it? Go to new column and then group lithologies. I hope you can all see.
Yeah.
Okay, so this is what will come. The base column is data set automatically, but you have to change it to lithology. Then give it a name. So I'll call it group underscore rock. Is that okay? Then you okay it. When you okay it, this is what will come. These are all the lithos, the codes in the lithology tab. So you need to group them. That is if you know the acronyms they are forming, then you group them. I don't know what AP is. The only thing I can identify here is the K. We have the dike, GRA. I don't know whether it's graphite. We have the Griwaki 2 here. We have the Griwaki. Then I think no sample recorded is here. NRE. There are a whole lot of things here, course here. I don't know them. We have this. So we have the SS could be sandstone. So for the training purposes, I think we just need to group them like that, because I don't know whether this is Abore and it's like it's the old thing. I mean, they are old data. Are we okay? They are old data which we may not know which is which. Ideally, we should be able to differentiate. I mean, to fish out all the metasediments and group them, and fish out all the metavolcanics. If they are graphite, we should fish them out and then group them. But I don't know if we know them. I don't know them actually. So I'm going to group all A's at one, group all B's at one, group all C's at one. That's what I'm going to do. But this is just for a training. It's not for any assignment. So if you get data in future you want to group, you can group based on you can group metasediments, metavolcanics, if they are working.
terms of being consistent in our logging.
Yeah, so is the, you see, now we have spoken about the modeling of the various lithology. It is the reason why actually we need to make demonstrate professionalism when it comes to the logging. We don't just log, especially the court. If you are modeling the court, maybe this distance there's court and maybe it's ignored or the weight is misplaced. At the end of the day, it will affect the density that you are assigning to that. Is it the actual rock that we said it is? So it is very, very important for us to do our best when it comes to the logging too. So I'm going to group all these. So I'll just, so in fact, if you look at this, you can play with them. These are the code. So you see that I can generally mute all or unmute them. So if I highlight one, then press control, I'll pick this, that. I'm grouping them. So you click on new group. So we don't know them. If they were meta segment, we just write meta segment, but we don't know them. So if you drop down here, these are the groups, the rocks you've grouped them under A's. If you come to the B, we just have one D. So I just new group. Can leave it BR. So I have C. Yeah, this C, 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 C. I'm grouping them. I hope you all can see. Then I click on new group. So that is C. If you drop, you've seen them. You've seen them here. They are those you have grouped. Then we have D. This might be diorite. This is dike. So new group. So that is the D.
Yeah.
Then we have the F. So I hope we are clear. We have the F's. So if I highlight them, the new group. So that is F. Then you have the G. G, 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 R, G, S, G, T. This is green wacky. So new group. So that is the G. Then we have the H. H is only one. So I can just move it there. I think this might be laterite. So new group. Then we have the N. NG. Recorded also no call. So new group. So that new group will be N. Then we have OV, OVB, so the O's. So if you highlight them and then you click on new group, so that is the O. Then we have the phyllites. Phyllites, we know that can stand on its own. Then we have the QV. Those quartz, eh? Yeah. So that could be the QV. Then we have the saprock, eh? SST or saprolites, whichever. So I'm control, and then you highlight them. Then you click on new. Okay, yeah, there's another S, SI. This is SS. SS. So the S are many. So new group. So new group. So that's the S. Then we have the T's. but I think it was AV. No, there was no V. So these are two. I can just give them orders. So when you are done, these are the group in the C's, and these are the D's, these are the F's, these are the G's, H, L, N, O, phyllite is on its own, Q, V, the S, there are many, the T's, and then the others. So that is it about the grouping. So you click OK. That is it about the grouping. You can display, if you look at the top right side, we have show lithology, legends. So these are the legends for the litho. You can use this to make them solid. Automatically it gives you big, so if you, are you seeing my cursor? I think there's a pointer here. There should be a pointer somewhere. So,
It's PowerPoint that we can have.
it's PowerPoint. Okay. I hope you people can see my cursor.
Please, can you see the cursor? We want to hear your response.
Yes, sir. Yes, we can.
Okay. So this is the outcome of the grouping, but you see that they are cylindrical and they are big. The line radius is 70. The line radius is 70. That's the thickness of the host. So I've just clicked on, have you seen my cursor? I've clicked on that. Make line solid. Then I'm reducing this maybe to 5. So these are the lithologies. So if you want to see them, I've clicked on the edit colors. Edit colors. I can mute everything. What is seen there are traces. Which when you click here, show traces, they will all go. Now, if I want to see only A's, these are only A's. Lithology with the A's. If I want to see BR, it's only one. These are the lithologies with the C's. If you want to model them one by one, that is how you do it. You have to filter them. The D, I'm not even seeing. Yeah, so they are here. So is the S that's remaining. So these are the S. So they are the lithologies. Now, after grouping your lithologies, what you need to do is you have to create a merge table. The essence of the merge table is you want to group all, you want to merge all tabs with which has from to, the interval from to. For example, the first thing we are going to create is ASP, pyrite boundary or sulfide boundary. So you have to create a merge table for the sulfide boundary. So when you create a merge table for it alone, you can use it merge table to construct maybe load or shear. Each and every what do you call it, stage. The sulfide will have its own merge table, the shear will have its own merge table, the loads will have their own merge table, quart will have their own merge table, lithology will have their own merge table. So each one with its merge table. So to create a match table, you have to go to drill holes, right click. Then you see new match table. So this is a new match table. You can rename it. So I want to be consistent, so I'll give this one A underscore match table. Okay, match parites. So that is what I'm going to call it. That's a name. Eh? No, that one is going to come from here, the mirrors. So I will choose my axis, then I will choose rock, then I will choose the quote and then the star. I don't want data sets. So these are the mesh tables. These are the mesh tables. What you have in the sulfide boundary. If you go to the shears tool, it's the same, but you can remove the mirrorization out, the mirrors out. You can remove the mirrors out. If you go to the lows, it's the same procedure. So you okay it. So it has finished running. If you have a question, you pause and ask me. Okay. So this is the match table we have created. So if you drag it into the scene, this is the project tree. If you drag it into the scene, and then you see if you can toggle, you can change them. This is the mean star. This is the RC. Okay, so that is the match table. What we want to do next is we want to create a legend for the axis before we continue. So if you drop down and choose the axis, automatically, you remember I went to this make line solid to make the lithology solid. Same way, I'm going back to the axis. I just want to click the make line solid. They come cylindrical form, and then I will change here. I'll change the line radius maybe to 5. Make them smaller to view. Automatically, leapfrog creates a legend, and that legend is a continuous legend that it just gives you a default legend, but you can create your own legend. So we want to create our own legend before we continue. So to create a legend, you go back to the top right and you drop down. If you drop down, you see new color map. If you click on that, the first one is the continuous. That is what by default what leapfrog has given. We want the discrete one. Okay. So over here, see that you can see the highest AC is 353. So we want to start with 0.5. So this plus, if you click on it, you are adding. If you click again, you are adding. Now from infinity to 0.5, from 0.5, you can give it, maybe let's give it 0.7. So, 0.7. I'm deleting this, so I'll do it again.
Let's start with 0.25.
0.25.
Yeah.
Is this just a legend too?
Okay.
So
Legend.
After that, we just do this. So 1.3. Take this 0 to 0.5, 0.5 to 0.7, 0.7 to 1.3, 1.3 and above ceiling. I think this is okay. So have you seen how I've created the legends? Anyway, pay much attention. If you are unable after that, the recording, you can send it across, but pay much attention and understand it better. So this is how to create the legends. So I can change the colors. You just click on the color. I'll give this one green. And I'll give it blue. I'll give it green. I think this is fine. Magenta.
Yeah.
This is lavender. Oh, it's a magenta and a lavender. Okay, it's okay. Okay, so you can name it. You can name it. Maybe Ori Lake. Whichever, or you can decide to leave it like that. It's just for training purpose. You can leave it like that, or you can name it if you want to. So then you close it. I don't like the magenta color. It's not visible. I mean, it's not conspicuous.
Yellow.
I like yellow, red. So have you seen where I've gone back? I want to edit the colors. So I've gone back to the drill holes here.
Yeah.
Yes. This one, if you click on the cylinder, you delete it. But the pencil, I'm at the pencil. Okay. I'm clicking to edit it.
You said 1 hour.
It's 1 hour, but even the time has passed. The time has passed. It's 5:04. It's 4 to 5.
So, like where we can stop for them to try their hands on up to the legend.
Okay, so I thought I could use one day to do the ASB boundary because 1 week will not be enough for this training. Okay, so the leaf rock, there's some party here they are calling, and also we don't know whether are there some of you who has problem tomorrow? Yes, it continues tomorrow. Are there some of you who have problem in importing the data?
Please respond.
Do we have some people who has problem in importing the data? Hello?
Hey Ben, we can't hear you. Are you on mute?
No,
we
we are not
asked
on mute.
whether from the so far what we've done.
Yeah.
Do you think anyone can import the data?
Sure.
Do you think anyone can do the grouping?
Yes. Yes. Yes.
And how about the legend?
Yes. Yeah.
Okay.
You see, I just want to know, is it that if today is your first time of seeing how to import the data, it will be important to revise on how to import it. But if you already knew how to do it, then it's good. But looking at the time and your time, to the 1 hour actually is not enough.
Yes.
I don't want to bore you with something that you already know. That is what I mean. I don't want to bore you with something.
Some of us, this is our first time, so you're not boring us at all.
Yeah.
Okay. So what you do is that I know some of you have the license on your computer.
The African version.
Yeah, I have it.
But the leapfrog itself, is it installed on your computer? I mean, not your personal machine, but the company's machine.
Yes, it's on the main piece, the masterpiece.
Okay, so what I'm going to do is I will release the license for you now, so that you go and check it out on the company's machine, and you try your hands. That is, if you have the time on the import of, maybe tomorrow we'll have to increase the time if you have time.
Yeah. So, gentlemen, ladies and gentlemen, do you think starting at 4 is okay for you, and the 1 hour is okay for you? If not, we can change the time and extend it a little bit, so that you have ample time to, because it entails a lot. And if we are just going by 1 hour, we may be rushing and you may not get all the concept right.
Can we start? Can we start earlier than 4?
No problem.
What time? What time do you suggest?
Maybe 3:30 to 5:30. We can do 2 hours.
3:30 to 5:30. Okay. I mean, is that consensus? Is everyone agreeing to the time?
There's some people who are suggesting 3 to 5.
No problem. You people see yourself,
so
and then
please let's coordinate.
I think we'll also be considering the meeting, the 3:30 meeting also.
Yeah. So what do you suggest?
Mike, your hand is up.
I also think about the fact that some of us will come for night. As I'm speaking now, I'm getting ready to come for work. So eventually, it's not 5:30. I mean 5:30. You only help some of us.
Okay. Well, if you are at the work site, the best thing you can do is to come to the office early, so that you go through, then when the time is up, you continue work.
And to actually, if we make the time too long, we need a lot of things, and once you capture all those things within that community, quite difficult. So within a short time, we can capture something small, then we can pass it, then later maybe another hour and 30 minutes. We can also do another thing, then we can capture it, practice it before the next lecture starts. I think that will be helpful than doing this for a long time. We do a lot of things, and later we are not able to remember everything.
Okay.
Thank you, Mike. Eric's hand is up.
Yeah, okay. I wanted to know if we can break it into 2, like having 2 hours for that period. I think there will be a lot to do. So we have 1 hour morning session, then probably 3 to 4, another section 1 hour. I don't know if that can be done.
Senior citizen said it's impossible.
Okay.
Yes.
Right.
Yes.
I was also suggesting something about the data. If we could get maybe a data that we are familiar with, maybe data from maybe Dynamite or Encran?
Yes, I'll give it to you. I'll send it
And so that maybe we can all get maybe a training. Maybe we can select one particular data, maybe Encran drill hole data or Dynamite drill hole data, and use that for the training.
Okay.
But we've not finished the first discussion, and you've slotted in the second one, the timing. So do you think from 4 to 5:30 will be convenient to everyone?
So if we are coming from Obotan to Isase for night shift, when we switch to night shift, it might be a little bit of an issue because the bus also leaves Obotan to Isase at 4:30. So we are trying to see if we can get to the office at 4 p.m.
We say it's not a continuous training. There are breaks. So if you want to be part, then you have to sacrifice a little bit. In that case, you got to leave Obotan early to be at Esase and be part of the team. So, okay, Eben, we'll leave it for you, discuss among your team, and let us get the conclusion by the close of the day.
Okay, sir.
Right.
So please, if you don't have time this evening, then you have time tomorrow morning. Try and get the license and then practice a little bit. Okay.
Okay.
So we thank Cletison for today's session. We'll continue tomorrow when you get the time from you guys. But let's take this serious because you can put it on your CV. And if you put it on your CV, be ready to defend it. So let's take it serious and learn. It's free. You are not paying for it. And we appreciate his time giving us today's training. Tomorrow, I shall be on RDO, but I know that I will leave early, get to Takrade, and join you guys. Okay?
Yes, sir.
Okay, thank you.
Thank you. Goodbye.
Bye.